Okay, this first problem here you need to pay special attention to. It says I have $2,500 in my checking account. I spend about $300 per month from this account. I usually put more money into the account when it gets down to $500. How many months will it be before I need to put more money in my checking account? So 2 units, dollars in months. Now you got to pay special attention here to this one, this bad boy. X is months, Y is money. So per dollars per month. Now the dollars per month is 300, but it's actually a negative slope, a negative M, because if I'm tracking my money, it's going downward. So I got B plus MX equals Y. And Mr. M here is going to be take a negative 300 value, negative 300X. Now you had 2,500 to begin with. That's your B. Okay, and there's your equation. Okay, I've got 2,500 plus negative 300X equals Y. And we're not going to put 0 in for Y because we're not going to wait till it's 0. We're going to put $500. We're going to wait till it's $500 is equal to Y. Okay, so get that Y out of there and put 500 in it. 2,500 plus negative 300X equals 500. Now remember, my X is being multiplied by negative 300. So first we have to subtract the 2,500 from both sides. And 500 minus 2,500 is going to be negative 2,000. Then I divide both sides by negative 300. And that's my answer. Okay, so I take negative 2,000 divided by negative 300, and I get negative 2,000 divided by negative 300, and I get 6.6 repeating, okay? You can put that, it's a time unit, so you can have a variable. It'd be 6 2/3 months, but that's it. Okay, number 2. A company makes calendars from personal photos. You pay a beginning delivery fee for each order plus a cost for each calendar. The cost for 2 calendars plus delivery is $43. The cost of 4 calendars plus delivery is $81. Calculate the total cost of 15 calendars, including the delivery fee. So you got calendars and dollars. So whatever I'm buying is independent, and then money's dependent. So per dollars per calendar. Now I don't know that, but I know every calendar costs the same amount, so I use Y minus Y divided by the X minus X. That's how to find a slope. Okay, so my money is 43 minus 81. You can also go 81 minus 43. That's okay. But with $43, we have 2. Make sure you put a 2 under the 43, and make sure you put 4 under the 81. Okay, so what that gives me, it gives me negative 38 over negative 2, and that's $19 per calendar. So that's my M value. So B plus MX equals Y. Now we know the M is going to be 19, okay? Now the B we don't have any idea, but there's a delivery fee, so I know there's a B. So Y equals M times X plus B. Circle that B. Okay, and once again, I have my M values 19. And then I use the combo. And I can pick, I'll go 2 calendars, $43. Okay, so again, the calendars is X and the dollars is Y. Okay. So 43 is Y, and I take my 19 times 2. So 19 times 2 is 38. Okay, and 38 is positive, so we're going to subtract that. So 5 equals B. Okay, so my beginning cost is $5. So my equation is 5 plus 19x equals Y. Okay, and I put 15 calendars in the equation. Again, the number that goes into equations is always the last number that you get. But you got to be careful. You don't put 15 here, okay? Y is money. It's not $15. It's 15 calendars, so that's going in for X. So I replace the X with 15. And then Y is solo. It has no operations with it, so I can just plug that expression into my calculator. 5 plus 19 times 15. Okay, 290. So that is going to cost 290 smackers, $290. Okay, number 3. In one day, a movie theater collected $4,200 from 800 people. The price of admission is $7 for an adult and $8 for the children. How many adults, how many children were admitted to the movie theater that day? Okay, so again, you got 3 units this time. Okay, so make that table. That would be the problem-solving strategy I use here. Okay, so you got adults, children, and then together. And then how many per and total. Now put a $sign above per and total. Now the total cost together down here, we have that. That's $4,600. Okay, now non-money amounts, you got 800 people, but that's not adults, children. That's the amounts together. X, Y. Okay, now the adults cost $7 and the children cost $5. So I have an equation up there, and then I get one here because I write the expression 7x and 5y. So there's my 2 equations. So x plus y could equal 800, or 7x plus 5y could equal 4,600. Okay, so I have a 7 down there, so I multiply the top equation all by 7 and the bottom by 1. Okay, so that's going to be 7x plus 7y, and then 7 times 800 is 5,600. And then on bottom we have 7x plus 5y, and that stays 4,600. Negative, and then the 5 goes negative, and 4,600 goes negative. So that gives me 2y, and that gives me 1,000. So then I divide both sides of the equation by 2, and y is equal to 500. Okay, so that's your children, 500 children. And if you know there's 800 together, we just subtract 500 from the 800, and that's 300. Boom. Okay, number 4. An adult pass for a fair costs $2 more than a children's pass. When 378 adults and 214 children passes are sold, the total revenue is $2,384. Find the cost of each pass. Okay, so again, you got 2 units, adults, children, and money, just like you kind of did on the last problem, but it's not the same situation. Okay, so again, I go to my table. So I've got the adults, the children, and then together. And then how many, the amount per, and the money amount for total. Okay, so the money amount total is $2,384. See ya. How many? Well, we got 378 adults, and you got 214 children. Now, I'm going to add those together and write 592. I don't really use the 592 on this problem because I only need one equation, because it says an adult pass costs $2 more than a children's pass. So x plus 2 and x would be how to fill in these 2 unknowns. So x plus 2 is the adults, x is children. This is the only equation I needed, is on the bottom. So 214x. And then here I distribute 378 to both of these, and that's 378x. Then 378 times 2 is 756. Now the x's, man, just add them together. Okay, 378 plus 214 is 592x. Plus the 756 equals 2,384. Then it's just a two-step equation. I subtract the non-x term, the constant. That's 1,628. And then I divide both sides by 592. And x is equal to 2.75. Okay, now here's my x right there, and that's your children. So the children are $2.75. Now the other one's 2 more, so I take the 2.75 plus 2, and that's $4.75. Okay, number 5, you deposit $5,500 in an account that pays 3% interest each year. How many years will it take the account to reach $10,000? So you got dollars in years, 2 units. X is years, Y is dollars. So per dollars per year. Now there is no dollars per year. Instead, it's a percentage each year. So it's 3%. Now interest is adding 3%. Okay. So right away, what I want to do is take 100% and add 3%. So it'd be 103%. Divide that by 100, and that's 1.03. But this is a repeated multiplication problem, so it's not linear. I go to my exponential function. Blank times blank to the x power equals blank. This is my percent factor, and then these two factors represent the money. Okay, so this is original, and this is new. Okay, so the original money amount is going to be $5,500, and then my percent factor, 103 divided by 100 is 1.03. Now, we don't know the exponent because that's the years, and that's what I'm trying to figure out. So I circle it, and I know I'm using log over log at that point, but I got to put 10,000 then for the new. Okay, so that exponent, x, is equal to the log divided by log. And this here is on bottom, okay? Your base goes on the bottom. Now to find the top, you have to divide, not subtract, by 5,500, okay? That is a multiplication operation. The opposite of multiplying is to divide. So I take 10,000 divided by 5,500, and I get 1.82 is what I'm going to put. Okay, so I take the log of 1.82 divided by the log of 1.03, and that's approximately 20 years. So it's between 20 and 21 years, closer to 20. So that's your answer. Okay, number 6. A store sells 50 of a new model of DVD player for a period of time for $140 each. For each $10 decrease in price, 5 more DVD players will be sold for that period. After how many price changes can the store maximize their revenue, and what is a maximum revenue? So it's a maximum problem, and that's a coordinate point. So to find the x, you have to know the formula opposite of b divided by 2 times a. Okay, so it's a revenue, so remember what revenue is. It's the number of items, it's what you're charging for the item, times the quantity of items that you sell. Okay, so revenue, we replace that with y. And then the money, I got $140 and then $10 decrease. Now, the decrease happens over and over, so I put x. In the meantime, we got 50. Now, if I'm decreasing the price, I'm going to add then to the items, but again, that happens over and over, so 5x. Now, that's great. That's a great equation, but I got to get rid of the parentheses. Now, you can do the FOIL method, but then you run the risk of making a careless mistake, and it just makes your answer at the end look hideous, okay? So I need to put this in standard form. Now, I would recommend doing the FOIL on the Math Papa calculator. Okay, so I take 140 minus 10x multiplied by 50 plus 5x. Okay, and that gives me negative 50, x to the second, 200, x, and 7,000. Okay, and that's my A, that's my B. So the opposite of B. One thing you should not be doing is going to the GCF-T. Okay, that is not. Okay, you can get your x first. So the opposite of B is negative 200, and then I take 2 times negative 50. That's negative 100. And then I divide those, and it's 2. Okay, so I replace the x variables with 2. And that's going to be my, remember, plug it in correctly, okay? Because it would be much easier to find the x first. 7,200. And that's my maximum revenue, okay? So I would take away 10 twice from 140, so I'd go to 130 to 120, charge $120, and then I would be able to sell 50 plus 5 plus 5 is 60. Okay. Okay, last problem. A missile is launched from a 100-foot platform with a velocity of 600 feet per second. How many seconds is that going to hit its ground target? The ground is 0 feet. So I got feet in seconds. X is seconds, Y is feet. And the feet per second rate is 600, but it's not a slope. It's not an M because it's not a line. It goes up, comes down. So we start from 100 feet, and then we end at 0 feet. So get that gravity equation made. Negative 16, 600. Now the initial height's 100. And that 0 feet goes in for the y variable, okay? Now that leaves me with just x. So x has 2 solutions because it's to the second power. Okay, and you're equal to 0, so these x's can't be combined, so you go into your factoring, GCF and the t. So GCF, we're always going to need the negative. We don't need the x. Now I look up the GCF between 16, 600, and 100, okay? Rather than have to guess. Gives me a nice, 16, 600, and 100. Okay, I got 4. Okay, negative 4. Simplifies that a little bit. Okay, so it's going to give me positive 4x to the second minus 150x minus 25. Okay. Okay, 4 times negative 25 is negative 100, so that'd be a difference of 150. Problem is, you start at 1 and 100. Well, that's a difference of 99. That's already failed. Okay, you're too small. You're not going to get any bigger with the difference. So. Okay, opposite of B, opposite of B, plus or minus the square root, B squared minus 4AC over 2A. Okay, so the opposite of B would be positive 150. B itself would just be negative 150, but it's to the second power. Then 4, and A is 4, C is negative 25. Okay, and then the A value is 4. Well, I know 2 times 4 is 8. That's easy. So I have 150 plus minus 8. But what am I going to plus minus? I don't know. What's the square root? Second x squared, you got to have a second parentheses. So negative 150, close it. And after you close it, you do the second power. You just hit the x squared key without hitting the shift button. Then I subtract 4, and negative 25. Okay, so that's 151.33. Okay, so I take 150 plus 151.33 and then divide by 8. 37.67. Okay, then I take 150 minus 151.33, divide by 8, Negative 0.17. Obviously, I'm going with the higher answer, 33.67.